Yeah, so this is going to be, let's say, a real PLC exercise, which we could use. What we are doing now, we could also connect to some equipment in a process, for instance, a motor or a contactor or a relay or something, to manipulate this relay, make something happen in the process. What we're going to do here now is to program what we call a final state machine to control an actuator like this, but we are going to test it, emulate it. So if you look at the assignment, we're going to emulate this field equipment or whatever actuator that we don't have. Still, if you have one, you can use a real PLC to test it. So this is how to control, to program a final state machine. The last exercise too is a final state machine, but now this is for control function. We are going to define PLC I/O tags, and then we're going to learn to use TI portal and emulator function block, which is in the library on your template project, and the PLC simulator to test our function block. It's not a complex function block, but it's not trivial either. So they're going to program a function block that's called fcBistableControl, and the Bistable emulator, which is in the template project. We're going to look at the template project, how it looks afterwards. Have to call this in program main and in program sim. The simulator part in program sim and then in program main. So that's new, that we have something called simulator that we have to call, to program or have an entry in. And then we are going to test it by manipulating the instance in this instance data block. I'm going to show you how to make instance data blocks, and the documentation is copied. And here is the how to do this. And here is something. The instruction here are some small codes showing what should be in the program sim and so on. But I'm going to show you these programs here, and also how to make an instance data block, and the program listing here, but you have to type it in yourself, and then also this is the program you are going to make, documented code. That's what you are going to do, and then you have to test all this stuff. There's not much to the test, but you have to test it. And there's something here in your own words. Write in here, well, I did this happened, and this reason why it happened. And when you are going to explain the reason why it happened, then you have to understand what you have been coding. And then we have some exceptions. We have some fault information and stuff that's going to be entered here. So then we're going to test some exceptions. That's important. We have made a program that's going to control this element. Let's say I have controlled this field element, whatever it is, it's on, active. And then there's an error in the process, lose power, I don't know what, but it's not on anymore. And then we have to do something. We just can't control field equipment and say, okay, it's running, I forget it. If it's continued to run, I don't care. If it stops, I don't care. What's happened then? I don't know. If that's a pump that's emptying water out of a tank, maybe the tank is going to overflow. I don't know. But I might find out. My legs get wet, or I don't know what's going to happen. So what we have to do is to say, okay, my pump has stopped running. I have to do something. I have to give a message or something to someone. They have to do something, restart the pump or whatever. And what we do here is we have an output that's called YF, fault information. These names are codes, and YF is fault information. And here is some programming tips. Here's the function block that you are going to make, but there's a skeleton in there with these inputs on the left and outputs on the right hand side. This is just an example for a valve. It was not a pump, but a valve. with a control signal to a solenoid. Okay, so if the output is true, the valve opens, and if the valve is open, we get an open feedback. If the output of the solenoid is false, the valve just collapses and closes, and I get the closed feedback, and the open feedback disappears. Yes, and here's a description of how this should work, and here's a state diagram for the states. We're going to program a final state machine, fcSim, and here are the states. We have an initial state, and we restart our CPU, initial state. Okay, we look at the equipment I'm going to control. It says it's closed. I'll go back up here. This valve is closed. Usually it is because my output is false, because my PLC has been switched off. So closed, and then I jump to the state low. Low is closed, high is open, and transit high is when it's opening, and transit low when it's closing. And these arrows here is, let's say if I'm in low state and I detect a high command, then I go to transit high state, and then I have to set my control output, or else nothing is going to happen. And then I'm just going to wait for my XGH, which says it is open. And then I'm jumping to high state, and I still have to keep my output on, or else the valve is going to close. So that is not good. And when in high state, I'm waiting for XL, external low, go to low state. I want to go here, and then I go to transit low, switch off my output, and hopefully when the output is gone, when my valve up here, it's going to close. There's no power to solenoid here, so it's going to close, and I get the XGL feedback, and then I go back to low state. So it's like this, like that, up here, down, down, up there, down. So that's the cycle. The initial state is when the PLC is restarted, and then I need to know when my PLC restarts, and that's in the project template. Yeah. Here are some more programming tips you can read through, and here is programming flow coding tips to the block, and here are the inputs, but also static variables that you should use. This means that you can make an HMI for this valve, so you can control it from an HMI if you wanted to. These are static. And static, again, it means that as long as your PLC is running, whatever you write to this variable here is going to keep it. If you switch off your PLC, it's going to return to 0. And that's the reason why we use number for states here. So if I restart my PLC, these are going to be 0, so the states is 0. And up here, the next state, if I'm in low, my next state is high. The transit high is just something I have to do to get to high, to check that I'm getting to high. And when in high, my next state is low. I have to go through transit low, transit low to get to low. And if you go down here, this SI state is the actual state. So when I switch, the actual state is going from low, transit high, high. My next state that I control myself, I do control all these variables myself, is going to be low and high. My next state is where I want to go, not where the program is going to go next. That's the SI state, and my code that's deciding that. Okay, here is our program skeleton that you have to put in. And there's something written here already, and these inputs, look at these control inputs, they are down here in the in-out section, and those I can read, do something, I can delete them, and that's what it does down here. I see, okay, these are commands, and when I'm done, I do have what we call a compound set to false. XA equals XL equals RX, and they are all false. So first RX is false, XL is false, and XH is false. just to demonstrate component instruction here. But what you have to do, you have to enter something here, here, and here, or everywhere basically. Okay, so these are the programming tips. This skeleton is in the template project, or else there's also an exported source file that you can import with this skeleton. So if you now go down to the CPU, or the, no, it's not the CPU, TI portal, and look at this assignment, here is suggestions. I'm going to show you quick, I'm not going to do this, how to make an instance data block, these two, for function block. This is the skeleton. I'm going to open the skeleton. In the beginning, so what I've done here, I made some temporary variables. One that's for restart, and it uses the system function to get the first scan. Say, okay, someone has switched on the CPU, the first scan. I need to know that. And in restart, I have to do something. What I have to do here, just a tip, is to set my program to initial state. I have to get my program to go down here. So this is the case statement. Depending on what the state is here, to remove this one. Depending on the number here, if that number is 0, it's going to process the code that you put in here, but not go down here or down here. It's just going down here. And the output has to be true when you are in this state. No, not here. I mean here and here. You have to write something here to make y true when you are here or here. Else y can be false. The timing that you have to use, because when you switch state, you have to wait, because this is something out. These are maybe heavy components. Take some time to move this. If you go back to the valve up here, so this one, if the solenoid is switched on, you are not going to get the feedback open right away. The valve is going to take some time. It might be a second, it might be 30 seconds, depending upon the valve. It might be faster. If it's a relay or something, it's really fast closing. But it's not going to close. As you give the output, you can't expect to get the input right away in the same program. So you have to wait. And then you would have to do make timers. Timing down here. And here is the time tick that we read in. And this is in where we made a real simple function block, has this timing inside it. So then you have to do some timing down here. This one has to be calculated to something. I can tell you it's going to be the difference between that one and that one. Should be. Because if you then, as we did in that real simple function block, if I do update this one with long time, I can do timing. So in my states down here, if I want to restart, when I go from low to transit high, I just restart my timer. In transit high, I just wait. If I get here, there's an if sentence. Remember, I said if I get correct feedback here, which is XGH, I should go to state high. And if my timer, that's counting as long as I'm in transit high, my timer is just counting, the difference is increasing, and then I check against this one. And again, and if, I said, if this time is greater than this one, then that's what you write in code, then you output an error on this here, which is called transit high fault, this number. And then you just stay here, because you don't get too high, so just stay here. And then also here is, up here is the reset, because if I write to an error, an if sentence, down here, say if I write something, and if that if sentence is not true anymore, the value, the output here is what we call also static. This or this one here, the fault information is inside a static, which is written out here. So basically the YFI equals this static value here. There's not much more to that one. Then I have to reset it, because as the last if sentence I wrote something in here, I'm just going to remember that one, which means that my last error I have to reset, and that goes to somewhere, an operator or lamp or what. This error says something is flashing. There's a push button that you can push to reset this, or what you have to operate this valve. And then you have to reset the error. Let's see. Yeah, that's about it. So what I was going to show you is these two programs, and then make this instance data block. I'm going to open the program for the control. There was not much to it. fcBistableControl is called. Then there has to be something else in my emulator. So my emulator gets the output. The output from my control goes to my emulator input, and here is the emulator program running. And then the output from the emulator is input to my control. And here, I've written it here, but maybe I should do it somewhere else. So I've written here to the instance data block, so just to test it. But if I go back to my assignment here now, let's see, was this correct? I should do something. What I did the assignment was up here. Use PLC IO tags. Ooh. And here's a PLC IO tags. I go back to my program down here. I don't need IO tags to do the simulation, but I should use IO tags here. I know IO tags in my program, and those are called PLC tags. Let's see, are the IOs? Yes, I've entered IOs here. Valve 01. These are earlier ones, but here are IOs, but I'm not using them. Well, then this emulator here is going to react on my output. So this should be the output, the Q, the command, the output from my PLC to the valve, open. So this one should react on this one. And here I am calling the simulator, but these are basically for my program. There was just a long call in my control here. There are two ways I can do this, but here are the feedbacks. So this is the feedback. So this would be input to your PLC and not from an emulator program later on. Should be this one. And now I remember, as I use these codes, this one should be XGL. Okay, so now my fcBistableControl just gets feedbacks, gets these values. And the name is wrong here too. Ooh, no, II, QI. they are not integer values. And here the system we are using, it should be called Boolean. IB. See if I hit that one too. Right, a B. Yeah, I think it looks okay. IB. Okay, now that's fine. I go back to here. QB. Oh, I don't have to change that one. And in here, oh, it changed to IB. And that's also for in TI portal. These variables names that they use, they are basically hash codes. These are just text. And it uses a code which is used everywhere in the program, and it says, okay, I changed the text, and then I just changed the name for the code in the program. So that's going to propagate everywhere in my program. That's kind of nice. Okay, let's say the original program I started with here in the programs would work, but what the assignment says, you should use IO. Okay, so here is the BistableControl gets it feedback. The output is just going to output card and out in the field, so there shouldn't be anything down here. But my emulator here just gets the output there. But now what I have to do is that I have to return. There's no one writing to these variables here for my emulation. No one is writing here. Well, it has to be the output from this one. This output's here. That's why I just made a copy. I didn't delete it. So here, I could take a copy too, but now I could say, what were they called? I think they were Q, E, IB, IB. Okay, there. SGH. Now I just take a copy down here. That was L. Okay. So where I started would work, but the assignment says do want to compile it. It looks okay, and I'm running the simulator, so to test this I would have to download. I can do that here too. Okay, so now it's all agreed. So that was these two programs here, and they should be called in main. Let's check. Program BistableControl, yes, that was this one. So my control should run that I've been making. That's this, an instance of this function block. This is the skeleton that you have to fill in. And let's see in simulator. Yes, looks okay. It's in there. And then just a quick look in the tasks. The background is, see what that was. Okay, here's the simulator where I called my valve emulator, which is basically in the library. Here, instant. Yeah, that's called. Okay, so that's called. So at least I'm executing that code. And as this one, the program called here, is writing to the program I called or to the inputs, it's going to be picked up in my program main and do something, hopefully. And then this program here is looping all the time. So iterations all the time. So the program main, where I have the, not the emulator, but this one, this program is outputting an output, writing to an output, and the emulator is picking up the output. Let's say if I now want to make this completely correct, I have to do this. Is the emulator handles the feedback and the output is handled here. So I have to write this, but now I have to do this here. Oh, I have to write this one. I have to go back and fix what I think I did. I hope maybe I did like this. So now it's completely here. This one is written to from this instance data block. See what happened over here. Oh no, I wasn't. Oh, I can rewrite this. This one here, of course, has to get the input. That's called X, and again equals. So that should be QB that one. So that's the IntelliSense. It was quick, and maybe I should bring back my comment too. Transfer control output to emulator input, and that was here. There's a little more. Transfer control output to emulator input. Yeah, well, that's okay. That's what I'm doing here. Okay, I'm just gonna download to get this all green. Yes. Okay. I started woodwork. So now I would have to. The reason why I did this now is that when I'm done here, let's say this is a RIA program that I'm going to use in a RIA PLC. What I can do here is that I can just delete in prgSim that I have here. I can just delete this one or comment it out or something like that, and then there's no emulator. So when I go back here in my fbBistableControl, these are real inputs and this is a real output. That is basically, if I go here in device configuration, see what happens. This is an input card with addresses 0. That's what I had in my IO table, I think. Input 0, the two first channels on my input, and the second, there's another assignment using the output 0. And here. So if I do connect something to these modules here, just by, in my simulator here, just by deleting this one, I can take my program out and check on a real starter or open a real valve or something like that. But I could do the testing in the lab or in my office or whatever. So there's quite a bit here. So we ended up with these inputs here in the control, but of course someone has to read this one, get into the emulator, and there has to be the feedbacks. You have to write to those also in the emulator. So now it should work, hopefully, but that's for you to test. What the last thing I should show was to make instance data blocks. The easiest type, this one here, of course, it's just here I could do here, add new group. These folders, they're called groups. But if I point at the group and add new block, it's going to open a dialog. It's going to be a data block. It's going to be an instance data block, IDB test. I'm going to just delete it. And then I have to find, if it was the emulator I'm going to make the instance for, this, which is this one. I just call it test. Now I get a new instance inside here. That's an instance. It opens it for me too. It just looks like the emulator instance. I'm just going to open that one. They look fairly identical. Close that down. The test, I was just to show, I'm not going to use it. Select it, push delete. Yes, I want to get rid of it. And then I'm back to OK, because now it's all green. I deleted the block. To do the testing of this, what you do is when you are done your program is working, you have to test it. What you do here is you open this one and look for the glasses like this, and what you're going to manipulate, what it says is this one, these two, to get the valve to do something and reset the error and so on. And that's just a double click here. You want to toggle the value, false to true. Remember, these are reset in the program. If I go back and look at the that was not a program where we had the skeleton. Down here at the end of the program, these are reset. So if you do set these to true, they're just going to return to false. You can't see it because the PLC is so ultra fast, so you can't see that. And for the other tests here, we can go back up here and look a little in the testing. On the emulator variables. Yeah, on the emulator variables, yes. Well, then we will have to open this data block. It was is open, and look for glasses here. And again, what this is going to do is if I do the emulator, it's going to change the outputs here. So what I'm going to do now, I'm just going to make a split. You see, that was the bistable control. That was probably lucky that I got that one over here. So these outputs here are of course the same as the inputs here. So now my control element says it's in low state. A valve then would be closed. So if I just force it high, yes, it changes and it goes to true. And here I get an error out of my function, the YFI, and what the program is. Let's say that was my skeleton here. No, it's up here. What a constant. It wrote 2. So what I've done is 2 feedback fault low. It was in low state, yes, and it switched to high. So there's a feedback fault in low. That's, as far as I'm concerned, that's what it is, and it is also in low state. So what I can do is I try to reset this one. That's this one. Try to make it down. Operate. Yes, I can switch this one off. Doesn't reset. That's the reason why. The errors is still there. The feedback was false. It's not correct. I can. So now we can just toggle. So if it goes back to, so now I'm back in state 1. And if I now try to reset this one, now there's no feedback error. It's okay. Moves to 0. And also, if I look at the emulator, it says it's 5 seconds transit time from false, from low to high. That switches off until this one switches true. So now I can do here in this one. It says I want to go to high. Opposite set. Nothing happened. Transit. I should get another error. I did, because it's still, this one is forced to low. It doesn't change. So it doesn't change. Now I would have to just go back. That's just the way the emulator works. I just go back to low and try to go back to high. So now it changes. Okay, so I got another error here, yes, because I had forced it low and I tried to operate it on it. It didn't want to move. Now I should be able to reset that one. 0. And it's the same if I now say I can do the same here, force it to true and try to close it. Like so. The output turns off, but nothing happens here. And then I got arrow 4. If I go back to the skeleton, there you have it here. 4. Transit to low fault. Yeah, that's correct. Of course, I'm just hitting myself one. So I gave a low command. So it wants to go to 4. It wants to go to state 1. And it just stays in the transit state, so it can't go low. That's the reason why the emulator here just says, okay, I'm not going too close. But again, if I go back to high, it's fine, and I can reset this error. So that's the way you do test using the emulator. And the last one was feedback fault. I can show that one too. Let's say now in high state. So I can force both to high. So I should get an error after some time. That was number 1. There's a time delay here too. It's 5 seconds. The feedback fault, I could change that, but I don't want to wait 5 seconds. 1 second. So I got that error, and I can try to reset it. Just reset, because the feedback is false. So now I'm just going to say, okay, both feedbacks are back to normal. Reset the error. Fine. So I can use also, say, remove both my feedbacks. Now I have no feedback. That's a legal one, because it can be in transit. Both feedbacks high, then you have a short circuit or something on the feedback, or well, there's something wrong on it. So I got that one, can't reset it because the error is still there. And then I remove my go slow, and I can see I can reset it. It's this value that I'm writing to, so I can write whatever I want in there for. I get it out, but I can still reset it. And what does was the skeleton? That one. Now I just remove the split here. There. And I can remove this one. And that is the reset here. I do a reset, and it is down here. The RX is set to false. That's the reason why I can't see this XH, XL, RX. I can't see those. Yeah. And the errors, they are set in here. When I'm in low state, I had to check for these feedbacks, XGA, XGL, are they correct? And if not, I have to wait some time, and that's where you do the timing up here and write those out. Yes, that should be enough of the tips. Then okay, so that was a walkthrough through the exercise, and you have the document, read there, look a little on state machines and stuff, and try to work on this. And of course, there's going to be a solution. So what I showed was the programs that I used to call this instance data block, and that was set up to test without I/O, to do a quick test. But the assignment says you should use I/O. So they had to reprogram for I/O, and then I showed a little on how to test using the emulator, doing split screen and look at the instance data block at the same time and work on this. Okay, this is by no means an easy assignment or exercise. But try to work on it. You get a skeleton, you have to use if sentences basically, and also case sentences, and so on. So it's final state machines. So just try to work on this and see how far you get. And of course, there's going to be a suggestion afterwards how to solve this program, and then I'm do a little more testing, even though I did a little testing on the program that I already had pre-programmed.